Hi all, I am Kashish of EL6303. Today I am going to explain to you question 1 of homework 1, and the question says, for any arbitrary event ABC, prove that probability of A union B given C is greater than or equal to probability of A union B union C divided by probability of C. So starting with our first step, consider a part of the equation probability of A union B union C. So consider this part of the question. So probability of A union B union C, as we know, can easily be expanded into probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C plus probability of A intersection B intersection C. Considering that to be equation 1, we move ahead. This part is a little cramped up, but I'm going to read it out for you. So now going to the left hand side of the equation, which is probability of A union B given C, this part of the question. So this is basically conditional probability of A given M. So using the formula of probability of A given M, which is equal to probability of AM divided by probability of M, we can write this as probability of A union B intersection C, or probability of A union B C divided by probability of C. Now when we open up this term here, which is probability of A union B intersection C, what we get is probability of A intersection C plus probability of B intersection C minus probability of A intersection C intersection B intersection C, whole divided by probability of C. Let this be equation 2. Moving ahead to the next step. Now from equation 1 and equation 2, from equation 1 and equation 2, we can put the values in our main prove that question, and when we put these values in our main question, this is what we get. We have substituted P of A union B union C by equation 1, and we have substituted P of A intersection B given C, P of A union B intersection C by equation 2. And this is what we have got here. Our next step is a simple mathematical deduction where we just open these brackets. So coming further down, on opening up the brackets, many terms get cancelled on both sides, starting with the probability of C that gets cancelled on both sides, continuing to probability of A intersection C, probability of A intersection C, probability of B intersection C, probability of B intersection C, and on this side probability of C and probability of C. What we are left with on the left hand side is minus probability of A intersection C intersection B intersection C. This, when logically thought of, is basically A intersection B intersection C. So we simply write this as minus probability of A intersection B intersection C, which we leave the greater than equal to sign right here, greater than equal to, and what we are left with on this side is minus probability of A minus probability of B plus probability of A intersection B, which can be written as probability of A plus probability of B minus probability of A union B, and minus probability of A intersection B intersection C. So now on both the sides, this term and this term gets cancelled, and out here this term, and this term, and this term, they cancel out each other. We are left with 0 greater than or equal to minus probability of A union B. Coming to our last step. So 0 greater than or equal to minus probability of A union B. Since our RHS is negative, it is proven that it is less than 0, less than or equal to 0. Thus LHS is greater than or equal to RHS, and hence we have proved that probability of A union B given C is greater than or equal to 1 minus probability of A union B union C divided by probability of C. Thank you.